All right, 5.6, last example, example C. Example C. Oh, I didn't use my new cool gray background. Ugh, oh well, anyway. Okay, so example C. Here's the problem. An initial deposit of $500 is invested at 8.5% interest. And this is compounded. Sorry about my little kid handwriting. Once again, I didn't get that nice thin little marker I'm looking for. Compounded annually. And then the question is, how long will it take until the balance grows to $800? Okay, so just get the problem copied down, and I'm sorry I didn't give you a handout of this one. This one's a little bit longer. I forgot that there was a little bit longer problem in here. But make sure you get this copied down. So this is now an applied way we would use logarithms. So we're going to still write the exponential growth equation that we've been talking about whenever we talk about investing at a certain percentage rate. We're still going to use that equation, but now we're going to apply logs in order to actually solve for x instead of just guessing and checking. So I'm going to go to the next screen here, and I'm just going to put down the important information. So the initial investment, initial money is $500. The rate is 8.5%, which is equal to 0.085. And y is the amount after x years, which is supposed to equal $800, and the number of years is what I'm looking for. So the equation that I'm going to have here is $800 equals my initial investment times 1 plus my percentage rate to some x power, and this is what I'm looking for. How much time? How much time is this going to take until my money ends up being $800? So I'm going to go through and I'm going to solve this equation. So let me go back. I'm going to erase this information here. I'm going to rewrite actually my equation at the top of this page so that you have some room in solving. Okay, so the equation again was 800 equals 500 times, times 1 plus 0.085 to the x power. So I start out by just using my straight up algebra. So I divide by 500 both sides, leaving me with 1 plus 0.085 to the x power, and that equals 1.6. Okay, so 1 plus 0.085, I can definitely simplify that. That just equals 1.085 to the x power. Well, now I have an expression in the form of b to the x equals a, do I not? Here's a, here's b, here's x. So I can now use that form where log of b, a equals x. So I'm going to transform this equation that I have originally 1.6 equals 1.085 to the x power. I'm going to transform it into the log equation. So I end up with log of b, which is 1.085, a, which is 1.6, is equal to x. And then I plug that into our lovely calculator and end up with the fact that x is equal to 5.76, which means it takes about 5.76 years, or if you want to calculate it, it would be 5 years, 9 months for my initial deposit of $500 to equal now $800 at that 8.5% interest rate. All right, so just a little real world example of using logs. Hopefully you have all of your examples down and you're ready for practice the next time I see you in class.